Today we're going to learn how to draw Lewis structures. Lewis structures are critical in understanding the types of bonding in covalent molecules, polarity, the shape, and several other things about molecular interactions. It is imperative that you learn how to draw these and draw these correctly. It's not a hard skill set to master, but it does take some practice. Okay, here are several things that the Lewis structures will allow us to do. It will allow us to understand the orientation of the atoms, bonds, and lone pairs of electrons in a particular compound, a covalent compound. They are 2D representation of a 3D molecular shape. So what we're going to be drawing is a 2D representation of what the molecule looks like in 3D space. It's going to help us determine the molecular polarity and the amount of polarity. It also will help us understand intermolecular interactions like hydrogen bonding. I'm going to teach you how to draw Lewis structures through a set of sequential steps. Following the steps will always get you the correct Lewis structure. Step 1. From your formula, determine if you have a central atom. Basically, if you have more than two atoms, you're going to have a central atom. So for example, CO2 has 3 atoms, 1 carbon, 2 oxygen. Therefore, one of those atoms is going to be the central atom. HCl only has 2 atoms, H and Cl. So therefore, won't have a central atom. If you do have a central atom, how to determine which one is the central atom? Well, it's going to be almost always be carbon, and it will never be hydrogen. So if you have carbon in your system, generally carbon is going to be the central atom. Next thing you're going to do, once you have your central atom picked, you're going to draw that on a piece of paper, and then around it, symmetrically, you're going to put all the other atoms, right? So if you have 4 other atoms that you have to put around it, you're going to make like a cross or a square, right? 3, you're going to make like a triangle. 2 more other atoms, you're going to make a line. All right. If you only have 2 atoms, obviously you put them next to each other. Connect each of the outside atoms to the central atom with a single line. This is a single covalent bond of 2 shared electrons, right? Now, one thing you don't do, you do not connect any of the outside atoms to other outside atoms. They all get connected to the central atom only. Then you're going to look at your periodic table, and you're going to determine how many valence electrons does each atom bring into the formula, sum them up to get the total valence electrons in the formula. For every line that you drew, bond, you're going to subtract 2 electrons from the total number of valence electrons. The resultant is lone pair electrons. This is the number of lone pair electrons that you have. Once you have the number of lone pair electrons total, you're going to add them all back onto your structure in pairs of 2 to the outer atoms first, then the central atom if you have to. All the outer atoms get 6, except hydrogen, which gets none, because hydrogen already has its duet filled. So you can add up to 6 electrons on the outside atoms, but none go to hydrogen. Once you are done that, you're going to have to move the lone pair around to achieve full octets of each atom. Remember, hydrogen doesn't get any more than it has already connected because it only needs 2. All right, I'm going to show you how these steps work in the following examples. Okay, our first example is one of the simpler ones to do, and that's HCl. So we're going to look at this and say, do we have a central atom? Well, we only have 2 atoms. And the 2 atoms are H and Cl. So we don't. So we're just going to go back and we're going to draw the 2 atoms together and leave a little space. So we're going to have H and then Cl. Okay? Now, when we do that, we're going to now connect them with a single line. And there it is. Right? Now I'm going to change color to represent the electrons. Now it says determine the total valence electrons. So we're going to put 1 here because that's how much hydrogen has, and the valence electrons of chlorine is 7. So the total of them up is equal to 8. That's 8 valence electrons. Now we're going to subtract 2 electrons from each bond. So how many bonds do we have? Well, let's circle it right here. There's the bond. And for each bond, we have 2. So we're going to subtract 2 electrons. And the total electrons that we have to add back on are called our lone pair. And there are 6 of them. Now the lone pair get added to the outside atoms first and then the inside atoms. But we don't have any outside atoms because they're both outside atoms. But we do know that we don't add any to hydrogen. So we have to add all 6 to chlorine. So let's put them all on. 1, 2, 3, 4, 5, 6. Now the final thing we're going to do is check that we have an octet around each one. Now remember, hydrogen doesn't get an octet, it only gets a duet, so it only gets 2. So you draw a little imaginary circle, everything that's connected to the chlorine counts, right? So we have 2 here, 4, 6. Now these 2 count because they're in that imaginary circle, they're all connected to chlorine, they're being shared, so those 2 count. So 2, 4, 6, 8. So that counts, and that means it has 8. It has completed its octet, so that's good. Now we do around hydrogen, and there's 2 there. Now we can count these twice. Why? Because they're being shared. So they're being shared by here, and they're being shared by this atom. So that counts 2. So there's my 2 here, 2. That's it. So we have completed this. So this right here is the Lewis structure for hydrogen chloride. So our next example has a lot more atoms in it, and this will going to be used to show you that it has a central atom. So the first thing we ask is, does it have a central atom? And it does, because it has a lot more than 2 atoms. So it actually has 5. So what do we think is the central atom? Well, we said in almost all cases, if it has a carbon, that's the central atom. And usually the central atom is always listed first. So carbon is listed first, carbon is in the thing, so we're going to say carbon is the central atom. So we put carbon here. So carbon here. Now, on the carbon, we're going to symmetrically put around all the other atoms. So we're going to put an H here, an H here. Now, it doesn't matter where you put the H's. They can go anywhere along here, as long as you put them symmetrically around the thing. So you could have put the H here and here, but we don't have to. You can put them anywhere you want, because don't forget, this is a 2D representation of a 3D shape. And in real space, this is a tetrahedral, and you don't know that yet. But it doesn't matter where you put them, as long as you put them in a symmetric pattern. So this is a 4 pattern thing. Then we connect them up like we're supposed to. Let me just change that to the correct color, because I don't want to confuse you yet. Right, and then we'll connect that up to the correct color. So we put 1 here, 1 here, 1 here, and 1 here. Okay, so now we're going to, we've done that, so now we're going to determine the total number of valence electrons. So let's do that. So we have, there are 1 carbon, and that times 4 of those, so that's 4 electrons. And then we have 2 hydrogens, and each one brings in 1, so that's 2 electrons. And then we have 2 chlorines, and each one brings in 7, so that's 14 electrons. So the total, when we add them up, is 20 electrons. That's the total valence electrons. Okay? Now, from that, we're going to subtract the number of electrons that we've used in the bonds. So we have 1 bond, 2 bond, 3 bond, 4 bonds. So from this, we're going to subtract 4 times 2 electrons. Each bond is 2 electrons. There are 4 bonds, and so we have a total of 4 times 2 is 8. 20 minus 8 is 12. So we have to add 12 electrons, and this is my lone pair. We have to add 12 electrons back on. So let's do that. We're going to keep them red. And so we add 1 here, that's 2. I kind of like to balance it out, 2. And then we have 6 total, 8, 10, and then 12. Why didn't we add any to the hydrogen? Because the hydrogen can't get any because it already has its 2. Right? Now we just do a count to make sure we did it right. So this chlorine and this chlorine look the same. So as long as we have 8 around this one, we probably have 8 around this one. So let's count them. There's my circle. So we have 2, 4, 6, 8. And just to make sure that I show you that with this one is 2, 2, 4, 6, 8. Now just make the hydrogen. There's my 2. We can only get 2. Here's the other hydrogen. There's my 2. Now we've got to make sure that carbon has 8 because it's the central atom. It still needs 8. So there's our circle around this one. That's 2, 4, 6, 8. So everybody wins here, and this is your Lewis structure for methyl dimethyl chloride. Okay? Right there. All right, next one. Okay, so here's an example of one that we're going to have to move some electrons around. So the first thing we're going to do is, do we have a central atom? Yes. And what is our central atom? Well, it says almost always carbon, never hydrogen. So we have hydrogen and carbon, so it's not going to be the H. Why can't it be the CN? Well, it's a good question. The reason is because we always generally look for the least electronegative element, and carbon is that compared to nitrogen. But generally, as I said, if it's carbon, go with carbon to start with. So we're going to put H, leave a space, C, leave another space, and then N. Now our next thing to do is connect them up. So we're going to connect them up, 1, 2. And now the next thing we're going to do is we're going to calculate how many valence electrons. So that's the valence electrons. And then we have 1 here, 4 here, and 5 here. So there's the total of 10 electrons. Those are my valence electrons. Remember, we have to add them up. Okay, so we have 10 valence electrons. All right. Now we're going to subtract 2 for each bond that we made, and we've made 4 bonds. Here they are, 1 bond, 2 bond. So we're going to subtract 4 electrons for the bonds, and remaining equals 6 electrons in lone pair. Right? So now we're going to put them around. 1, 2, 3, 4, 5, 6. Now, what we need to understand is, can we see that we have 8 electrons around each one of our atoms, except for hydrogen. Hydrogen needs 2. So let's just do hydrogen right off the bat. There's my 2 right there. So we're good. Now let's do nitrogen off the bat. 2, 4, 6, 8. That's good. Now let's do carbon. 2, 4. That's not good. So now what we're going to do is, carbon is deficient in electrons for its octet. So it's got to borrow them from somebody else. Well, it can't borrow from hydrogen, so it's going to borrow from the nitrogen. So what it's going to do is it's going to borrow these 2 electrons, and they're going to come from the bonding set down into, lone pair set down into bonding set. They haven't moved, and they've only moved. They're still attached to the nitrogen, but now carbon can share them. Now, if you still do the count, we've got 1, 2, 3, 4, 5, 6, 7, 8. So that's good for the nitrogen, and now carbon has 2, 4, 6. So what are we going to do again? We're going to do another borrow. We're going to borrow 2 of these, and we're going to put them right here. They haven't gone off the nitrogen. They just moved from one section to the other of nitrogen. The analogy I always use for students is, let's say you have a party and you have like a parade coming down your street, and you have 6 chairs in your backyard, right? And your neighbor comes over, and you were already sitting in your 2 chairs in your front yard to watch the parade. And your neighbor comes over and they don't have any chairs, but they want to watch the parade with you. So what do? You just go to your backyard and bring out 2 of your chairs so your neighbor can sit in them. They're still your chairs. You get them. They're still your chairs. They haven't left your property, but now your neighbor can sit in them. So now that we've done that, let's make sure that we haven't violated any rules. So let's do our count here again. We have 2, 4, 6, 8. That's good. Now it's carbon. 2, 4, 6, 8. That's good. And then the hydrogen, there's 2. So this would be the Lewis structure for hydrogen cyanide. Okay, our last example will have electrons that actually will fall onto the central atom, right? And this is important to understand, that it's not always the outside atoms that get all the electrons. Sometimes the inside atoms will get extra atoms too. So let's try that. All right. So we're going to, again, which one of these do we have a central atom? And we do. But there's no carbon and there's no hydrogen. So which one are you going to choose? Well, you have 3 iodines and 1 phosphorus. So my guess is that the phosphorus is going to be the central atom. So we're going to put the phosphorus here. Let's make the color correct. Sorry about that. Let's erase that. And then we'll go to this. And so we'll put the phosphorus here. Now it's iodine, so we're just going to put 3 iodines. 1, 2, and then 3. Now the next thing you do is we connect them up. So there's 1 connection, 2 connection, 3 connection. Now, the next step is to determine how many valence electrons each has. So each iodine, let's going to go down here. Each iodine, there are 3 iodines, and each one brings in 7 valence electrons. And then we have to add the phosphorus, and each phosphorus, there's 1 of them, 1 phosphorus times 5 valence electrons. And so the total is 3 times 7 is 21, plus 5 is 26 valence electrons. Now, how many bonds did we make? We're going to subtract 6 valence electrons for the bonds. And so we have 20 valence electrons that we have, or excuse me, not valence electrons. They are lone pair electrons that we have to add back on. So we can add up to 6 on all the outer atoms. So let's do that. So we add 1 here, 2 here. I kind of always go around. So so far we've used 12. And then that's 18. Now we still have 2 lone pair electrons that we have to add back onto the structure. Well, we can't add any more to iodine, so we have to add it to phosphorus. So we'll put the 2 right here. All right, so we've added all 20 back on. So now we have to just do the count to make sure that we didn't screw up. So let's do the count around each iodine. Now remember, all the iodines look the same. So if we do 1 and they turn out to be 8, the chances are the other ones are going to be 8. So there's 2 here, 4, 6, 8. You can count them here. 2, 4, 6, 8. 2, 4, 6, 8. Now the phosphorus, there's 2, there's 4, there's 6, and there's the 8. So the phosphorus, again, 2, 4, 6, 8. So we've gone through multiple examples of how to draw Lewis structures with different scenarios. The first scenario we did was just a linear molecule, HCl. The second one we did had a central atom. The third one we did had a central atom and requiring you to move some of the valence electrons around from lone pair into bonding pair. And the last one, we didn't move any lone pair into bonding pair, but we had to put a lone pair on a central atom. So if you have any questions about it, send me a note to class.